Hello, today in this video session, I'm going to show you step by step how to use YOLO V3 to detect objects on the images and the video. Let's start. So we are going to follow this OpenCV tutorial to try using YOLO V3 for object detection. And history is quite hard to follow and at the first glimpse if you read this tutorial. So that is exactly the motivation I'm going to do. I'm not going to add and share a clear step-by-step explanation for you. And also we are going to using the open source computer vision library, OpenCV. And some extra bonus, I'm going to add some useful utility functions to ease your understanding and also add object counting analysis code. And besides that, also I'm going to add some object detection on the video stream code. Okay, let's move to the notebook. So object detection on the YOLO V3. As we know, YOLO V3 is actually the very fast, accurate, and real-time, and it's open source and it's free. So this is the main motivation why we want to using the OpenCV and then YOLO V3 framework to do the object detections. Okay, so in this notebook, so I'm going to show the step-by-step detailed code and instructions to how to enable the object detections on the various images and the video clips. Okay, right. So this is the 80 Coco dataset classes, and you can let the YOLO V3 to detect. So because YOLO V3 is trained on the Coco dataset with the 80 different object classes. So that covers the most common stuff like the person, bicycle, cell phones, chair, ball, banana, apple, skateboarding, tire, suitcase, cat, dog, horse, sheep, and so on. So that's quite good and to cover a lot of the stuff in our daily life. Yeah. So the first of all, you can download some sample images for the experiment. So here is the code. So for the first time running, you can just activate this cell and just change it from the raw to the code, and then you can able to execute and download all the sample images we are going to use for this experiment. Okay, so now I'm just deactivated. So move to the next cell. Here, visualize the image samples. So if not yet, you can first install the matplotlib, the library for the data visualizations purpose. Okay, and then I just define some utility functions and to process and visualize the images. Here, if I execute the cell, you can see this is some samples. Okay, showing up different things: horse riding, dining table, street, traffic, zoo, kitchen, airport, sport, and so on. Okay, so how to use YOLO V3 is pretty straightforward. First of all, you just need to download the pre-trained YOLO web file and also the YOLO configuration file. Then in the second step, you just need to load the YOLO network model from the hard drive into the OpenCV. Okay, so this is some code you can just download and install the OpenCV. If you're not yet done so, you can just activate this cell and install the necessary dependencies. And then after that, you can just disable it. You don't need to download it every time while you're running the notebook. Okay, and then in the second step, just import the dependencies and then give the configuration and the web files of the YOLO V3, and then load the YOLO V3 model into the OpenCV. Okay. Okay, after that, and you can take a look at all the deep neural network layers of the YOLO V3. Basically, YOLO V3 is a deep learning model, and it has 254 layers and components as shown in the diagram below. So if you want to take a look at all these layers name, you can just print out. So this is all the layers name. Okay, in the second step, after you load and the YOLO V3, then you can just create the right data format or the input image for the YOLO. So because the YOLO expects a specific format for the input message, and which is called the blob object. So this function is to the purpose, and this takes some following the input. Okay, so following input, and then so the basically a blob object is a 4-dimension 9p array object. So images, channels, width, height. So for example, below is a blob shape of one images, 3 color channels, and 416, 416 width and height. So that is the basic format for the blob image object. So here again, I define another utility function. So when user click any keyboard key to exit the OpenCV visualization, okay, and then we can construct a blob object from the raw image, okay. So you just read the image from the hard drive into the memory, and then you create this blob object. You can see the original image is in the shape of the 375, 500 width and height, and then 3 color channels. Then the block object has the shape of the 1, 3, 416, 416. Okay, this is the right format. Okay. So after that, you get some your image data ready. Then in the third step, you are going to using the YOLO V3 to predict the objects with the speed accuracy. So the following 2 instructions, okay, is actually to specify the input, like the blob object as the input to the YOLO network, and then you actually to calculate the network response. Okay, so the output is actually the 2-dimension arrays in the shape of the n rows, 85 columns. Okay, so where each row contains like 4 bounding box coordinates, cent x, cent y, width, height, and then 1 bounding box confidence score. That is, if an object detected there, and followed by 80 core dataset class confidence scores. So that is what class of the object it is. Okay, for the n, it can be 507, 228, or 8112. Since YOLO has 3 detection outputs for handling objects of the various scales, large, medium, and small. So you can see this is for the large, this is for the medium, and this is for small. Okay, so that is the output, network output. Okay, so then in the next, we're going to have some quick test. So actually we set the blob object as the input to YOLO network. Then also I just like to try to calculate the how long it is, the latency for the object detection using the YOLO V3. Okay, so if I just rerun this code, okay. Oh yeah, so because I have to run from beginning, you know, let's like run it from beginning. Okay, so okay. Okay, now it's working. Okay, you can see the original image shape is this in this shape, and then we actually prepare it into the right blob object format expected by the YOLO V3. 1 images, 3 color channels, width height is the 416, 416. Okay, so and let's take, you know, this command just like realize the blob object. Okay, I just like taking like the green channel here. You can also like specify the 0 for the red channel, 2 for the blue channel. Yeah, because this RGB image format. Okay, so let's actually take a look at the visualizations. If I go to here, you can see this is like the blob object. So this is our first sample images or horse riding. Okay, and okay, so just like to exit it. So okay, next, we're going to actually do the object detection using the YOLO V3. Okay, so and as we said, so this is if we actually execute this stuff, you can see once I running this code chunk, so it tells me it takes about 0.85 seconds, just 850 milliseconds for the YOLO V3 network to detect the objects on this sample image. So basically, the YOLO V3 we can see have 254 components and layers. So this net dot forward, so output contains 254 outputs for each layer respectively. So this is why the output type is the list, and its length is 254. So if you take a look at the first layer output is in this shape, and the last layer output is in this shape. Okay, so as we will soon see later on, so there is only 3 out of 254 layers actually are useful for the object detection. So we're going to actually take a look soon. Okay, and just take a look at these sample images. This is the sample images we just visualize. Okay, now yeah. Okay, this is the sample images. Okay. Okay, move to the next step. Okay, so here yeah, again, so it told me it's take about like the 0.6 to 0.8 second in my MacBook, which only have the CPU and have no GPU. That is why it take a bit long actually to detect objects on the images. So in the production, actually, you're going to using the GPU, actually the powerful GPU cluster to actually do the real-time detections. That is the practice, for the production environment. But however, currently we just do some pet project, just have some fun, do some experiment for the data science, and for this purpose, just using the laptop is okay. Okay, so and in the following, I'm going to show you the NetMe, our sample image detection. Okay, so line by line, so just some detailed code to do this kind of job. So first of all, we import the dependencies, then we just like load some sample images here, and then you can show the sample images. This is our raw image. So then we can just like to to visualize the active Coco dataset classes. So and then this is give us the configuration and web files of YOLO V3 and load the YOLO V3 network into the OpenCV backend. So then next we are going to decide the output layers. Just said is only 3 out of the 254 layers are actually the useful output layers that we are going to need for the object detection. So these 3 output sources actually just for the handling the bounding box objects of the varying scales, large, medium, and small, right? So okay, this is the one. So then we can just print out YOLO output layer names for the detection and so on. Okay, so if I execute this line, you can see it tells me YOLO output layer name for the detection is YOLO 82, 94, and 106. Okay, these 3 layers is going to be useful for our object detection purpose. Okay, just move to the place. Okay, so next, so we are going to construct a blob object from image. So that is the code that we already done before, and so we just like take some samples like these red channels for visualizations. So you just visualize it, and then you can just wait for the people's the any key click and to exit the visualizations. Okay, so if I go to here, you can see is here is So what's the name we're giving it? Okay, blob. Okay, yeah, blob. Okay, the window we are giving it is blob. Okay, you see this is a blob um, um, visualizations. So you can see, and this is our horse riding, the red channels, and I'm going to show you the the how is actually all this bounding box is drawing. Okay, so let's move back to this notebook. So now we set the input for the network or this blob object. Then I calculate latency for the object the detection. Okay, so then just tell me for the horse riding image, how long it takes for inference, and output type, length, and the number of bounding box detected in each output source. Okay, so if we see, I just execute it, and it told me it takes about like the half second to actually detect objects in these images, and the output type is the list is 3 output sources. This is actually take care of like the large, medium, and the small objects, right? So the number of the bounding box detected in each output source is at different with different scale. So as we see before, this is the right format. Okay. So also let's move to upstairs. Okay, here and right. Okay. Again, as we said, right, you got a 3 output for the handling large, medium, and small objects. Okay, so that is the shape n multiple 85. Okay, so for the next code, this is the tracking bar. Okay, visualizations for the tuning the bounding box confidence threshold. So it's basically adding the confidence bar actually to the image blob windows, and then just demonstrate how the bounding box visualizations is decided by the bounding box confidence threshold convertible by the sliding bar. So the x is the actual value given by moving the sliding bar. Okay, so when I move the sliding bar, this tracking bar, so the confidence threshold will be recalculated. Then when new threshold value is given, we actually need a new copy of the blob object on which to draw the updated bounding boxes. Okay, so then for like all the outputs, and we just like to check if its bounding box detection confidence score is greater than the confidence threshold. If it is, then we are going to visualize that bounding box. Otherwise, it's going to be no visualization for that bounding box. Okay, and so this is the idea. So this the when you change the sliding bar, so the bounding box confidence threshold will be changed, and then the number of the bounding box will be changed correspondingly. Then all this will be realized in the our blob window. Okay, so that is a blob window. Okay, and then this is actually explain the CV rectangle. Basically, this function is just like draw the rectangular bounding box, um, uh, as requested, when you actually changing the bounding box confidence threshold. Okay, so this code is actually to create the track bar, and this is the track bar using the calling the functions above. So the default values and input to the track bar is 50. Okay, so that is like and because it's range from 0 to 1, it's divided by 100. It's actually the default value is starting from 0.5. Okay, so let's take a look at the visualization. You can see this is our bounding box confidence threshold. We just defined it, bounding box confidence threshold. So this is the track bar we just created and is associated with the blob window. Okay, so that is associated with the blob window. Okay, so you see now this is using the default bounding box confidence threshold of 0.5. So this is all the quantified valid bounding box is realized. So if I change, let's see, if I change the threshold, you can see the correspondingly the numbers and the location of the bounding box will change it correspondingly. Okay, so that is the just show you how the threshold of bounding box confidence threshold going to be impact the visualizations of the bounding box for the object detections. Yeah, okay, going back to the notebook. In the next, we are going to go to the YOLO V3 object detection loop. Okay, this is the main loop. We are really interested. First, I am initialize some global variables, bounding box confidence threshold, and also the object class detection confidence threshold. Okay, and then I going to actually define some list to actually to contain all the valid bounding boxes and also the corresponding the object class detected and also the detection confidence scores. Okay, so okay, just move a bit up. Here. Okay, so in the following, you can see we are going to find all the valid object detections whose confidence score is greater than the predefined threshold. Okay, so here, for each of the 3 output sources, largest, medium, small, and then for each detection out of each output source, which is a 2-dimension array, n multiple 85, if you remember. So just see the bar. So the index, the 5 to 84 is actually the contains information for the 80 Coco dataset class, the confidence scores. And then we actually using this kind of line code to actually get the top one detect the class ID, and then the corresponding top one detect the class confidence score. Okay, so these 2 lines code. And then if the object class detection confidence score is greater than the predefined confidence threshold, okay, then we accept it. Otherwise, we are discarded. Yeah, so only accept the detection if its score is better than the threshold. Okay, and then if it's quantified, so we are going to calculate the bounding box coordinates. So this line, such lines of code, I just like to do this purpose. Okay, so once you know that, you just add the valid detected objects class ID, detection confidence score, and the bounding box to the list. Okay, so you can see we just append all these valid bounding box coordinates, the object detection confidence scores, and the object class IDs into our predefined list. So we're going to use it and to actually visualize later. Okay, so after you do that, here we can see, just like show for this sample image, we're going to show how many valid objects are detected by the YOLO V3 before applying the NMS, the non-maximum suppression. So we're going to talk in a minute and what is the NMS. Okay, so here you can see the number of the bounding box detected in each output source is different with different scale. Okay, the bounding box confidence distributions. Okay, so you can see the for some bounding box is detected with a very high confidence score, and some is with very small, very low confidence score. Okay, yeah. So this is why you need to define some threshold, and then you need to decide what is the valid detections, what is not. Okay, so for example, now we say for the image, this sample image hot riding. So the 31 valid objects are detected by YOLO V3 before applying the non-maximum suppression. Okay, so let's say it's the initial result, we get it. Cool. And okay, so after that, you are going to apply the NMS to generate the final object detection result. Okay, So NMS basically reduces the multiple and potentially partially overlapping bounding boxes for the same object detected by selecting the one with the highest confidence score. Okay, so that is the idea. So you have to define some like NMS threshold, which is a tunable hyperparameter, and also just calling this one line code, and this will automatically calculate the the quantified object class and bounding box the indices for you. Okay, so this is the result we want, and then we are going to this indices is a subset of all the in the indices in the originally detected result. Okay, so you get rid to index shape, so we can see it for the immediate one. We're going to see like how many valid objects are detected by YOLO V3 after applying the NMS. So you can see originally we got 31 valid object detected by the YOLO V3. Now we only have 10 valid objects are detected by YOLO V3 after applying the NMS. So that is very useful. So the idea is here, right? So you can see for like the same object, like this person or this house, you can see multiple overlapping bounding box. So the NMS basically just like to eliminate the duplicated bounding box, just like to identify and decide which bounding box is going to be the most likely one and just realized in the final result. Okay, so you can see here, and once we do the detections, so it shows just like the single bounding box for each object, for horse, for the person, for the dog, for the truck, so this is very nice clean result and visualize. And also a bunch of people also has been detected at the background. Right. Just moving back to the notebook. So finally, we actually rendering the YOLO V3 object detection result after applying the NMS. So this is just using the shortlist indices and to actually filter out the bounding boxes and then finally to add the the bounding box on the image blob object and also show the detected object class and the confidence score text. Then after you draw all these bounding box and texts on the blob object in the memory, so finally you actually to visualize the image with all the detection results to the end users by calling this line code. Finally, if the user click any key, and will execute these visualizations. So here it is. We already see it. This is our YOLO V3 detecting results with the confidence score, and you can see this one. If I this is our blob to showing like the multiple bounding boxes before the applying NMS. This is our raw images. If I click the keyboard, it will just all disappeared, and then we move to the next chunk of code. So now in the next chunk code, we can put all together to detect the objects in multiple images. Right. So it's pretty much the same thing. I just define some utility functions, to load the images, to do the post process, and to show the object counts. Actually, this is the new BetaLog new counting analytics code I'm adding here. So sorry, just like try to show it. Let me to show it. So here, just like move it line by line. Can we show it? Difficult. So you can see the right. You can see this kind of code is actually my own analytics code to actually count the objects of each type on the image frame. So this is the purpose. We're going to see like the counting result, calling these utility functions. Also, this is the tracking by to actually tracking objects. Yeah, okay. When you actually to change it like the detection confidence threshold. Okay. So here and then you can create the tracking by on object detection demo. Okay, image issues. Okay, that's good. And basically, this line of code is just create some new windows for visualization to the end users. And this one is create some tracking by on top of this window, on top of this window with the same window name. Yeah, so this window, and this tracking bar, is called the confidence. Okay, and then it's called this function tracking bar. Tracking bar is defined here. Okay, that's fine. Okay. So once you are doing that, you can just like calling all the utility functions. So post process, image output, and so on. So this is all, we already see it, in the previous, code chunk, load the images and do the post process. Okay. So all defined together here. Okay. Now we're going to running this code. Okay, I just rerun this code. You can see we're just using the class object class confidence threshold 0.2 as a good starting point. Okay, so I move to the visualization. You can see now everything has been. Can you see? Everything has been detected. Our object detection demo. So if I change the tracking by, this is changing the object class. Is different. Previously, we showed like the bounding box confidence threshold. This is not the different thing. It's the object class detection confidence threshold. Okay, if I change it, you can see actually changing like the object, has been detected and sometimes. Okay, and then if I click on return, you can see for that horse riding, it give me my custom analysis code, give me like counting of each how many persons, how many dog, truck, and horse, on that images. Okay, also like the showing the object detection confidence score distributions. Okay, quite nice. So it's quite highly confident, 99%. So minimal is also 24%. Okay, not so bad. And for this, we can repeat this procedure to look at the result for each every sample image. This is for the dining table. See, this is also a lot of dining table of wine, glass, okay, and so on. So if you look at it, and the result is showing the counting, yeah. Okay, let's see the counting is here. This is all the result when you are changing the tracking bar and to change the detection confidence threshold. Okay. Okay. Okay, yeah, here. Okay. You can see this is wine, glass, and bowl, Okay, this is also being detected, So if this is the traffic on the street. So if you can hit it, you can see like the person, car, bus, traffic light has been detected. Again, zoo, and the kitchens, and the airport, tennis sport, dining table, beach, Okay, so for each sample images, so you can see nicely the object and has been detected with the bounding box, and also my counting analysis code give us some like countings of each object numbers and on each single sample images. Okay, orange is the kitchen, this is the airport, this is the sport, tennis, tennis racket, nice. Okay, and so on. Okay, wine glass, this is for the beach, 4 person, 1 dog. Okay, nice. Okay, nice. Okay, so in summary, so YOLO V3 is pretty good at detecting various objects in the images of various sizes and skills and in the the nearly like a real-time manner, because I'm just simply running it on my local MacBook, so it's a bit slow. It's nearly like the 600 to 800 milliseconds, but actually when I test it on the GPU server, it's much quicker. Okay, so also in my another tutorials, and I'm also showed how to using the YOLO V4 to detecting the objects. So the YOLO V4 is much faster than YOLO V3 running on the GPU server, and also the tiny YOLO V4 is even better, even quicker, and yeah, you can check out that video tutorial as well. Okay, here I just give some like the how to using OpenCV library for the visualizations, and you can take a look, and it's quite useful. So, and then not only like on the static images, right? So, and we can also like using the YOLO V4 to detect the videos, right? Okay, so the video virtually is just like a sequence of the image frames for streaming detection. So except this, the pretty much the same thing as object detection on the static image, right? So the most code is reusable. So this is actually the just bunch of code, that I developed, and for like the how to using the YOLO V3 to detecting the objects on the videos. So basically, it's just like it's just to check out, the let's see, it's here. Okay, so it's just like to read like the image frame by frame out of the sample video, and then you actually to detect using the YOLO V3 to detect objects on each image frame, and after that the detection result will be written to some target the output images with all the bounding box and the object class text detected. So that is actually the code, for this purpose. You can see like this is some like the sample videos I'm going to input. So then the prediction result can be written into some output video. I'm going to specify this one, output video, okay, and before you can see. So also something to notice here is actually the many different codecs on the different operation systems and the platforms. So the codec is really platform dependent. So my code is just working for the MacBook, but actually also I show many other codec, right? So just like to adapt this part of the code to your own computer's operation system versions, and that is important. Okay, and okay, so after that you can start in the loop actually to read into each image frame out of the video, and then do the detection, and then write the result to the target output video clips. So you just repeat this procedure until you running the YOLO V3 to detect all the video image frames. Okay, so this is the basic code entry. So I won't go to the much details, but just like the pretty much is very similar for the static image detection. Besides, it's just like a sequence of the images from the video. Okay, so actually when you run it, and it take a bit longer. So and also you can originally the FPS frame per second for this sample video is 25. So because I'm running on the laptop, right, it's pretty slow. For example, if I just want to actually to my YOLO V3 to do like the 5 FPS, so I have to reduce the frame rate, right? So this is actually that just to manually to sampling the image frames. So here is the code, here's the code, you can see here, right? This line code. So I just manually do the sampling. So for example, the original FPS is 25, right? So I just want to actually sample like 1 image frame out of every 5. So I just divide by 5. So the resulting, the FPS will be just like 5 FPS. Okay. So this is also the 5 PS as the output FPS I'm specified here in this line of code. Okay, so this is another point to be paying attention. Of course, this is just like manual sampling. It's quite naive actually. So also it's a more professional way in my YOLO, how to using YOLO V4 to do the object detection. So I showed some code actually just using like the FFmpeg actually to just one line code to actually to do the sampling for the same purpose. And you can check out that video tutorial as well. Okay, so here we just like simple and dirty solutions and to sampling the image frames and to actually make the detection is a bit faster, on my running on my laptop. Okay, so you can see, and I don't need to repeat the detections, but actually the result is showing up here. So this is some street, the videos, and this is output detections. If I running this, okay, you can see detecting the handbags, persons, the umbrellas, and yeah, so it's quite nice. So this is the result from the YOLO V3, and running on my laptop without any GPU, just a CPU. So it's pretty good, not so bad, right? Okay, so yeah, so just like to have fun by yourself and to get your hands dirty trying running code. Yeah, so you can see like the result, and also you can download any free the videos, images, and you can try using the YOLO V3 to test on the different video images by yourself. Okay, right. Okay, so let's move back to our last slide. Okay, so today, step by step, I have walked you through how to using YOLO V3 to detect video image objects in an easy way. Give a like to me if you found my tutorial is useful, or subscribe to my channel if you like to download the whole notebook code for your study and the reproducible research. See you soon in the next session.